Hello and welcome back. So we just finished a fantastic few segments and now it's time for our math challenge. So I hope you're ready, I hope you're excited. Let's go ahead and dive into today's problem, which is the rainy day problem. So let's take a look now at the specific diagram and see what's going on here. So first of all, we can see that we've got some sort of platform here. Okay, that's 1 meter by 1 meter. So it's 1 meter squared. And we can see that there are some raindrops from maybe a cloud up above that are falling on this platform. Okay? So this is actually a special device that we've created, we've imagined. And this device counts the number of rain droplets hitting a 1 meter square platform every second. Okay? So some rain is going to fall on this platform, and it's going to count all those raindrops and then put them into a log, okay, a data set. So that's what we can see here. So in the first second, we counted 100 raindrops. In the second, we counted 107 raindrops. In the third second, we counted 92 raindrops, and so on and so forth. Okay? And we have all the way down till 8 seconds. Okay, so we've got some data here. We've got some data. So let's go ahead and take a look at the actual problems that we want to solve here. So the first problem, P1, we want to know what is the mean, median, and mode of this data. So if you don't know those terms, this is the opportunity to go ahead and refresh yourself on which are which, because they can be a little bit tricky. But go ahead, you can go ahead and look up what the definitions of these three are and find each for this data set. So hopefully that's not too hard, not too difficult. Our second question is a little bit more tricky. Our second question is, over what 5-second time spans do we find the maximum of the mean, median, and mode? Okay? So what does that mean? So that means if we took a look at the first 5 seconds, we can find a mean, median, and mode. If we took a look at seconds 2 to 6, or 3 to 7, or 2 to 7, or 3 to 8, right? We've got 10 data points, or 5 data points there. Oh, I think it should be 4. So let's see, 1, 2, 3, 4, 5. Yeah. So seconds 4 to 8. 3 to 7, 2 to 6, and 1 to 5. Okay, those are your time spans that you can look at. And you can calculate what the mean, median, and mode are for each of those time spans. And I want to know for which time span is each the greatest. Okay, for which time spans. So maybe the mean is maximum from 4 to 8 seconds. Okay, in that 4 to 8 second window, the mean is the greatest. Maybe the median is greatest between maybe the mode is greatest between 1 and 5, let's say. And maybe the median, again, is maybe greatest between 4 and 8. Okay, but that is your question for this problem. Okay, so don't go anywhere, because up next we've got some questions regarding our segments, maker highlights, engineering tributes, and so much more. So stay tuned. Hello and welcome to your rainy day solution. So if you remember, the problem was we had some data Okay, we were measuring rainfall, and particularly how many raindrops were falling on some platform that was 1 meter by 1 meter every second. And so we have our data here, up here, and the first question was, what is the mean, median, and mode of this data? Okay, of this data. So the first thing that we have to do is we are going to calculate the mean. Okay, so for those of you who don't know what the mean is, for the mean, the way that we can calculate it is we are going to add all of these data points together, and then we're going to divide by the number of data points. Okay, so the mean is going to be 100 plus 107 plus 102, plus 92 plus 120 plus 127 plus 135 plus 110 plus 82. We'll put all that in brackets, and then we're going to divide by the number of points or number of terms. 1, 2, 3, 4, 5, 6, 7, 8. 8. That will give us our median, our mean, and our mean is going to be 109.125. Okay, so that is our mean. It's 109.125. For our mode, there is none. Okay? So if you looked up the definition of the mode, what you'd notice is that the mode is the number which is repeated most in our list. Okay? So for example, if we had 100 up here and 100 down here, then 100 would be our mode. Or if we had 5 values that were 100, or 5 values, let's say there were 5 values that were 92. Well, 5 out of 8, no other number is going to be repeated more, so 92 would be our mode. Okay, so the mode is the point that is repeated the most. But none of these numbers are repeated, they're all unique. And so there is no mode for this data set. Okay, so the answer to that one will be none. And this TS maximum mode for our second question, for those of you who are eager, will also be, all, because all/none, because it's moot. There is no mode. Okay, for the median, this one's kind of special. So for the median, we have to rearrange these values, okay, from lowest to highest, and then we're going to figure out what is the middle value between all of these. So let's go ahead and do that. So we're going to arrange these into a list from lowest to highest. So we've got 82, 92, 110, 100, whoopsie doodles, 110, 107 would come next. Look at me. 107, 110, 120, 127, 135. Let's just do a quick count. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I've rearranged these numbers here from lowest to highest. And I'm just going to look at these middle two. Okay? This is how we calculate the mean. So we're going to order the list, and then we're going to choose the value that's either in the middle, if it's odd, or the two that are closest to the middle, or the two numbers that are in the middle, and we'll take the average of those two. Okay? So here we've got 107 and 110. And so what we're going to do is we're going to say 107 plus 110 over 2 is equal to our median. And our median in that case is going to be 108.5. So for question number 1, the mean is 109.125. The mode is none. There is no mode. It doesn't exist. And the median is 108.5. Okay, so that's pretty good. So for our second question, we had over what 5-second time span do we find the maximum, mean, mode, and median? And we already answered that there is no mode in this question. So the maximum time span, or the time span where we find the maximum mode, you could say it's all or none because there is no mode, right? So that's sort of a moot question. For the mean, we want to find where the maximum mean is. So one way that we could do this, sort of breaking things down, is we could start by, we could calculate them all, but that doesn't sound very fun. Rather, I'm going to look from 1 to 5, and I'm going to slowly move down one by one. And every time I move down, I'm either going to gain some values, or I'm going to lose, or I'm going to gain some, or I'm going to lose some. Okay? So for example, let's take a look at 1 to 5. Okay? So if I move down here, okay, if I move down from 1 to 5 to 2 to 6, you can see that I've lost 100, but I gained 135. So I'm up 35 points from where I started. So this one's looking pretty good. If I move down one more time from 2 to 6 to 3 to 7, I just lost 107, but I gained 110. So I've actually gained, by doing this, 3 points. Okay? If I go down one more time, I've traded 92 for 82. And that's not a very good deal. I've actually lost points there. So by following this logic, these number of steps, it becomes pretty clear that 3 to 7 is going to be our maximum mean. So that is what I'm going to put here. So our maximum for the mean is actually from 3 to 7. That is where you'll find the maximum mean. Okay, the time span from 3 to 5 seconds. Now the median is a little bit tricky. So the median, we're going to do sort of the same thing. Okay? And we care about which value is in the middle. Okay? We care about which value is in the middle. And if we arranged this set from 1 to 5, we would have 92, 100, 107, 120, and 127. So the middle value for this one, we'll write that one out. So let's do from 1 to 5. 1 to 5 would be 92, 100, 107, 120, and 127. So this middle value is our median, and that is 107. So the median from 1 to 5 is 107. Let's move down from 1 to 5 to 2 to 6. So for 2 to 6, we've lost 100 now. So we've lost a number that's less than 107. And remember this, because this is important. When we lose a number that's less than 107, we now have, well, from here to here, we have a new median. So we've got 92. We lost 100. We have 107. And then we've got 120. And then we've got 127. And now we've got 135. So now our median is 120. Now our median is 120. And if I go down again, we've got 92 to 110 here. We lost 107, but we gained 110. And the only difference for 3 to 7 is I'm swapping out this 107. So 92, we lose 107, we gained 110. 120, and you'll notice already 120 didn't move. Okay, so 120 for this one. And then finally, 4 to 8. Let's see. So from 4 to 8, we've lost 92, but we gained 82. So now we're just swapping out 92 for 82, and that doesn't help us either. 110, 120, 127, and 135. So there are actually more than one time span that give us the maximum possible median, okay? And that's 2 to 6, 3 to 7, and 4 to 8. So the answer for the time span or spans, that gives us the maximum median would be, and for the complete answer, you need to include all three, 2 to 6, 3 to 7, 4 to 8 seconds. And there we go. We have our three answers for problem 2. So first off, the time span that gives us the maximum mean is 3 to 7 seconds. The time span that gives us the maximum mode was sort of all, sort of none. You sort of choose there because there is no mode. So technically all of them give you a mode, okay? Give you the maximum mode, which is 0 or none. Not 0, it's not even 0, it does not exist, it's undefined. And finally, the time span that gives you the maximum median is 2 to 6, 3 to 7, and 4 to 8 seconds. Okay, so those three time spans will give you the maximum median. And we actually found out what that was. That maximum median is 120. If you're looking for a little bit of a bonus challenge, you can try and calculate what is the maximum mean from 3 to 7. Okay, but that concludes our solutions to the rainy day problem. I hope that you enjoyed, and we'll see you in the next one.